So in the center of your table, take 3. There is the same thing that I'm looking at. I've already highlighted this. So if you remember when we did the chapter right before winter break with all of the transformations, I had us go through and highlight, and it's kind of a time suck. So here's what I've done so far. Every group has one folder, one booklet. I've already uploaded my copy to Google Classroom, so you all individually have a copy of this booklet, but for use in class, we're going to use the one group one. Do not write in this, please, because I'm going to use it for all my classes. Please also leave it stacked in the center of your table when you leave. So one person in your group, go ahead and grab that little booklet. You are not making yourself the researcher. You're just going to hold it for your team so you know you have it. If you look through this booklet, so go ahead and grab it. Somebody grab it and display it for your team. Yep. We are learning today about what's called special segments of triangles. It is a vocabulary heavy day because we are learning 8 new vocabulary words, and they all have to do with different segments or little pieces of lines that we can draw on a triangle. There are 4. We have our altitude, our angle bisector, our median, and our perpendicular bisector. So that's already 4 vocabulary words. I'll go through them a little bit later. But each of these 4 vocabulary words has a point of concurrency for that triangle. A point of concurrency is where all of those lines are going to intersect. So this is a picture of concurrent lines. These are not concurrent lines. You see the difference? These all connect at one point. These do not connect at one point. These triangles, when you make all of the perpendicular bisectors, all of the medians, all of the different colors intersect, there is one point of concurrency, and that will be your 4 other vocabulary words for today. Go ahead and open this up for the first page. The first page is going to talk about the median. The median is a segment that starts at a vertex and extends to the midpoint of the opposite side. Do you see that pink line? Things that we know about midpoints. What does that mean about this segment AD and DB if this is the midpoint? If that's in the middle? What about things in the middle? What does the little tick marks mean? They're congruent. So it hits right in the middle, which means this side and this side are equal to each other. Yes? That's a median. Goes from a vertex to the middle. When you connect all of the medians, like in this picture here, so here's a median, here's a median, here's a median. They meet at this point right here, G. That is called the centroid. Say the word centroid. Yeah, kind of a weird word. Centroid feels like a robot, but it is called a centroid. We can find the coordinate of the centroid with the equation I have a little cloud around, or looking at the distance of that length. It's 2/3 of the distance. But today we're recognizing that it's the centroid. You might use that formula today, so you're just making sure you know where it is in this booklet. Flip the page. We're going to go over 2 new vocabulary words. A perpendicular bisector. Perpendicular means it meets at a right angle. Bisector means it cuts in half. So a perpendicular bisector starts not at a vertex, but at the midpoint, and it goes perpendicular to that line. Do you see that? It may not touch a vertex. In fact, it probably won't touch a vertex. But we have a theorem here that if we know something is a perpendicular bisector, that means that we know that the other sides are also equal to each other if it goes through a vertex. So that's nice. The point of concurrency where all of the perpendicular bisectors meet is called the circumcenter. Say circumcenter. Ooh, try it again. Circumcenter. Great, thank you. So the 3 different types of triangles, acute, obtuse, and right, may have a circumcenter at different points. So some are inside, some are outside, some are on the triangle themselves. But that is a circumcenter. So we're connecting perpendicular bisector and circumcenter. Flip the page one more time. I know I'm going fast, but it's because you're going to solidify this information later. We have an angle bisector. Angle bisector means that it's a segment that cuts an angle in half. So it starts at a vertex and extends to the other side, making sure that these 2 angles are perfectly equal to each other. They are congruent. The point of concurrency for an angle bisector is called the incenter. Say incenter. The incenter is always inside the triangle. It will never be outside, which is really nice. Check. We'll connect those 2 words together. The last words we're connecting together is altitude and orthocenter. Say orthocenter. Altitude is going to be your favorite one. because the altitude is like the height of the triangle. It starts at a vertex and goes straight down perpendicular to the other side. So it creates a height for our triangles. When we were in middle school, we did base times height for triangles. Divide by 2, this is what we were looking at, was actually the altitude of the triangle. The orthocenter is the point of concurrency, which means that's where all 3 altitudes connect. Take a look for a second at this obtuse triangle because it's kind of weird. I highlighted extra on this one for everybody. This is the actual obtuse triangle. If we notice, all of these perpendicular boxes mean that these altitudes are meeting way outside of the triangle, which is weird. For the other 2, it will be inside or on the triangle, but for an obtuse, it's outside of the triangle. This picture is just kind of funky, so I wanted to zoom in on that one for a second. Okay, now, whoa, that's a lot of words. Now, obviously, there's a lot of properties that go with these words, with things being equal in our different triangles. But what might be the most helpful page for you to connect these words together is the last page of this document. It has all 8 vocabulary words tied together with each other. See, my color coding is there on purpose. So perpendicular bisector is circumcenter. Angle bisector is incenter. Median is centroid. Altitude is orthocenter. And then the picture is there one more time for you. Now, obviously, there is no practice problems in this booklet. Your practice problems are going to come again with your groups on your whiteboards. So, what's going to happen here in a little bit is you're going to go back to your whiteboard that you were at. Make sure you take your marker with you, and you take this booklet with you. I'm going to come around with one question for each group to work on, and when you get that question done, you'll call me over to check it, and I'll hand you the next question. This is going to be more similar to what we did before, the break with the different levels. Does that make sense? Yes? Now, again, I have not really explained how to do practice problems. I want to see what you can come up with as you're working through these vocabulary words and maybe some of the information that's in this booklet. So you are going to have to work together to lean in and see what the booklet says and then work through the problems on your board. I highly recommend starting by drawing a picture every single time. So look for the vocabulary word that you were given and draw a decent picture.